Here we're going to look at an example, and it's part of your PowerPoint. After you watch the videos, I want you to go through the PowerPoints, but here I'm going to look at a specific example as part of the video. Suppose you're a purchasing agent for a large manufacturing firm and that you regularly place orders with two different suppliers. After several months of operation, you find that the mean number of days required to fill orders is 10 days for both suppliers. So whatever you're getting from them, it takes an average of 10 days for them to deliver it. The histograms on the following page show us what basically more information. They summarize the number of working days, the spreads and everything. So let's have a look. So company A takes an average of 10 days and so does company B. But company A has a smaller spread, or Dawson Company has a smaller spread than the Clark Company. That has a bigger spread of delivery days. So let me just spin this a little bit for you. Suppose that you work for a restaurant in downtown Long Beach and you're coming up to Valentine's Day and you want to put an order in for fish. And let's say you want to order salmon. Now both these companies can supply you. Both these companies will charge you the same price. Both these companies will give you the same quality of product. And both of these companies have an average of 10 days. You look at those graphs, which company would you go with? And you may say, well, I'm probably going to go with this first company because the spread of days is much smaller than the spread of days of these guys. I mean, these guys could potentially get it to me very quickly, but they could also take a very long time. But I'm more certain with these guys. So a lot of people are probably going to opt with these because even though the average delivery time is the same, we look at the standard deviation or the spread, and this company has a smaller spread than this one, and you're more likely to go with that company. Okay, so let's move on towards the end of the notes, the PowerPoints, and this example is mentioned again. It basically says our decision that we just made was really easy to make because the companies, everything was the same, the means were the same, the average delivery time was the same. The only thing that was different was the standard deviation. So it was an easy matter for us to choose the company which had the smallest standard deviation because nothing else was different. Then it says here, well, what would we do if the companies had different means? These two companies had the same average delivery time. If the means were the same, can we still just look at the standard deviations? If the means are the same, we can. If the means are not the same, should we still be doing that? So let's consider this example before I answer that. Suppose I told you I went out shopping in Orange County for something and the standard deviation, the spread in price was $1. And I said, is that big or small? $1. And you're going to say, well, what were you shopping for? If I said to you, I was shopping for a chocolate bar, so the chocolate bar, the price is $1 on average, and there was a spread in prices of like $1. So, I mean, I could get this chocolate bar for close to $0 or close to $2. You say $1 spread is pretty big given the average price is only $1. If, on the other hand, I told you actually I was shopping for a MacBook Pro. Now, let's just, for argument's sake, that the average price of a MacBook Pro is $1,000. And I said that the spread is $1. So you're saying, oh, spread is only $1. You know, a spread of $1 is not really that big. I mean, $1 up or down on $1,000 item is really small. But a spread of $1 up or down on a $1 item is large. So from that, hopefully you can see that what we're trying to do when comparing standard deviations is it's okay for us to compare standard deviations when the means are the same, but when the means are not the same, it's not as straightforward just to look at the standard deviation. Yeah, the one here, the standard deviation, I can't compare them. You'd agree that the standard deviation is not significant over here, $1 out of 1,000, but here it is. So there's something we should be doing, and let's go show that on the next page. We should be working out the coefficient of variation. What the coefficient of variation does, it actually takes the standard deviation and it gives you a value relative to the average price. So if we were to work out for the chocolate bar, let's say the choc bar, chocolate bar, okay, the chocolate. If we were to work out the coefficient of variation, it would be the standard deviation, which is $1, and that's going to be divided by the average price, which is $1, and we're going to multiply that by 100%, and that's basically going to equal 100%. That's kind of a large coefficient of variation, 100%. How about for the Mac? Well, for the Mac, what do we have? Well, the standard deviation we said is $1, and that's going to be divided by $1,000. Okay, it's the average price. So they both have a standard deviation of $1, and we're going to multiply that by 100%. And what does that equal? That equals 0.1%. Look at that. So look at this, the coefficient of variation here. The coefficient of variation is only 0.1, very, very small. Coefficient of variation up here is 100%. So even though they have the same standard deviation or spread, because the means are different, to make any sort of comparison, if you wanted to make a comparison for these, maybe you shouldn't, but if you're going to make a comparison, you really have to relate the standard deviation to the mean to make it more meaningful. And they have an example here which we can quickly have a look at. Suppose the average daily monthly starting salary of graduates of a business school is $3,940 with a standard deviation of $165.65. If we want to actually work out the coefficient of variation, we just take the standard deviation, which we're told is 165.65, and we divide it by the mean. And that's going to give us a coefficient of variation of 4.2%. So it's given us an idea of the spread relative to the mean.